look at this matrix and look at the first matrix. By the idea, I don't have to write 2 and the conjugate. I can write simply A star. Okay? So, you got the transpose. Then the conjugate of the transpose. You found yourself with the main matrix once more. So, this matrix is a Hermitian matrix. That matrix too is a Hermitian matrix. طيب جنى صح؟ جنى بصي على الماتريكس دي مش بتلفت نظرك في حاجه؟ مش دي نوع من الانواع اللي احنا خدناها؟ Guys, this matrix is one of the famous matrices that we took previously. Mr. Ziyad, can you identify the type of this matrix?
Square matrix.
ألف مبروك. Yes, it's a square matrix. And
Transpose.
إيه؟ بطيخ. إيه؟ Yes.
Conjugate.
Symmetric.
Ah.
So the symmetric matrices are those type of matrices where the elements are the same with respect to the principal diagonal. If you remark, that's the principal diagonal. شايف يا ندى؟ The elements 1, 2 is equal to the element 2 and 1. So this is a matrix of all real numbers. And also it's an Hermitian matrix. So the symmetric matrices are Hermitian matrices. This is why, because the conjugate of the real numbers, they are the same. يبقى أنا لو جبت transpose of this matrix, it will be the same. Getting the conjugate, it's also the same. Also for this matrix. شايف الماتريكس دي؟ الماتريكس دي برضو still A star Hermitian يعني. لأن لو جبت أول خطوة عملت transpose بعدين جبت الكونجugate ترجع هي. You should try it. طبعا ال 3 matrices all of them are Hermitian. تاني أنا معرف لك ال definition. Any matrix is Hermitian if A is equal to A star. What we mean about A star? Getting the transpose, then the conjugate. It will be the same. Also, you have a skew Hermitian or anti-Hermitian matrix. The skew Hermitian ده ايه الفرق؟ زي ال skew symmetric. مش انت عارفة symmetric matrices? Symmetric matrices, the elements are the same with respect to the principal diagonal. طب ال skew symmetric, the principal diagonal are zeros and the elements, okay, the upper triangle is exactly the lower triangle with opposite sides. هنا نفس الكلام. بص كده. ماتريكس اللي موجوده قدامي دي هرميشيان ماتريكس. لو انا لفيتها ورجعت عملت كونجيت ترجع للاصل. Okay, so to check if a matrix is Hermitian or not, you will have to do. Number 1, get the transpose. Number 2, get the conjugate of all elements. If it is the same, it's gonna be Hermitian. If it is, if you get this, if you do these steps and you find yourself in front of the main matrix but with negative sign, so it's a skew symmetric. Okay? I'm sorry, it's a skew Hermitian. طبعا those matrices, as I told you, those matrices are skew Hermitian, those are none. ده Hermitian, ده skew Hermitian, والأخير neither Hermitian or skew Hermitian. لو حبيت أجرب دي ماتريكس دي، بص عليها. First of all, get the transpose. طبعا لاحظ الماتريكس اللي سكيو هرميشيان زي السكيو سيمتريك نفس الفكره. تعال نشوف كده. انا عندي 0 بعدين 2 بلس 3i بعدين نيجاتيف 2 بلس 3i بلس u وده 0. ده الماتريكس بتاعتي. Let's get the transpose. Can you tell me that how it's gonna be the transpose? Change the rows into columns. So it's gonna be 2. The row will be 2 plus 3i. So the first row is coming the first column, and the second row is gonna be the second column. So it's gonna be negative 2 plus 3i and 0. So then the second step, get the conjugate of all elements. Let's get the conjugate of all elements. So it's AT conjugate. Let's do it. 0. Then the real part will remain the same, but the imaginary part will be with a negative sign. معايا جنى? For this guy, the main part, the real part will be the same. ندى بدل ما ده يبقى positive 3i, it's gonna be a negative of a 3i. And that's the 0. Let's remark the difference between this matrix and that matrix. What difference between these two matrices? Yes, negative sign. If I took negative sign as a common, I will find that negative is going to be 0, then it's going to be 2 plus a 3 over I, then it will come to negative 2 plus 3i and 0. So it is exactly like the main, but with negative mean sign. Which means in A star will equal to negative A times A. That's a skew Hermitian matrix. In the final exam of last year, I'm sorry, not in the final exam, but in one of the exams, either the midterm or the final one, the global exam, he stated for you one of the statements. Of course, the question was state or define which of the statements is correct. And he is giving you a matrix, giving the matrix A defined, and it is a Hermitian matrix. Is this correct or not correct? هتعرف انت منين? You will know this by taking this matrix, getting its transpose, and getting the conjugate. If it is the same, so this statement is correct. If it is not, so it's not correct. Are you with me? ماشي. انتوا لكم تعبانين ليه? Why you all look tired? So, why? We are still in the beginning of the week. Symmetric matrices are Hermitian matrices. خلي بالك, skew symmetric matrices are skew Hermitian matrices. They are special cases, of course. I'm talking about the real numbers. Okay. This part is really very nice, and I need to have your full attention in this part. We are going to the elementary operation in matrices. There is a bunch of questions. We'll hunt this part. How to do row operations on matrices. Mainly, we will define three main operations. Interchanging rows. Multiplying row by a constant number. Multiplying a row by a constant number, then adding it on another row. يبقى how many row operations that we have? Three of them. Those row operations are really essential. And in order to solve or to get an inverse or to treat certain type of matrices. Once more, the row operations are: number one, interchanging rows. Number two, multiplying certain row by a constant. Number three, multiplying a row by a constant, then adding the result into another row. These are the main three row operations. I will go through them with you step by step, and then we will take an example of how to manipulate this. But I will have to read first the slides, and I need your full attention for it. Let's remark this guy, this matrix. As you can see, the rows are in front of you. So this is row number 1. Blah, blah, blah. This is row number I. And so on. This is row number J. So, row number M. So this matrix, it contains n rows. Within those rows, you have the ith row and the jth row. لما أعمل العلامة دي, once you see this sign or this symbol, it symbolizes that we will interchange the positions of the ith row with the jth row. So simply, all I have to do is to take this row, complete this row. I will take it, replace it in the position of the red one, and the red one will come in its position. So, as you can see, we changed these rows. This is operation number 1. Row changing. I can change the rows. What's really will matter, usually in the other universities here in Egypt, we don't focus on how it is done, exactly how it is done, each step. We can replace the rows and that's it. We don't have to write that I've replaced the first row instead of the third row, or the second row instead of the first row, okay? But here you will need it. So this is why you will have to focus on what exactly are you doing. Replacing the first button instead of the second, or vice versa, or doing what. So that's the first operation. Any questions? Okay. ها؟ حبيبي هو الواد ده شارب حاجة صح؟ النهارده مهم؟
نفسي يا دكتور. نفسي.
طيب تعال نشوف نفسه ده يعمل ايه في نفسه. بص هنا الماتريكس دي how many rows? This matrix how many rows?
3.
Hey, once more how many rows? 3 rows. How many columns? 4 columns. طيب بص كده I will interchange the second row with the third row. So simply all I have to do is to take 3, 2, 2, 2, move it to the third one, and the third one will come into its place. Here we go. So I've replaced the position of these two rows. Leave the meaning of why we are doing this at the time being. It will appear later. But for the time being, you know that I have the right, if I want to change the rows of a matrix. Okay, really, very good. The second operation is multiplying certain row by a constant number. This is completely different than multiplying a matrix by a number. Because once you multiply a matrix by a number, you multiply all the elements. But I'm not doing this. I will multiply a specific row by a certain number. So, remark for the ith row. I will multiply the ith row by the constant alpha. For some reason, it will appear down the road. So I can multiply a complete row by a constant number. If you remark, each and every term of these terms I've multiplied by alpha. Just only for the row number R, or for the ith row. I say that this is operation number 2. Operation number 2, that's an example. I will multiply the first row by 2. So it's going to be 2, -2, 4, and 0. Here we go. يبقى أنا هنا بضرب مين؟ row واحد. We are doing multiplication in one row. By the idea, it can be performed on columns, but we will concentrate on rows. We are not going to do it in columns. Although it is correct, but we are not going to do it. Okay?
دكتور
قول.
أنا لازم أكتبها كده ولا
Yes.
أعملها من غير ما أكتبها؟
Yes, you will have to. Because زي ما أنا قلت لك, in other universities I don't have to. Because in other places I will focus with the final answer. But here he will ask you about these steps. And more than this, he will gather the elementary operations, as you will see down the road. So
multiple choice the steps count?
no, it's not going to count. Hopefully, we wish that they will count it, but it's not going to be counted. This is going to be needed in the elementary operations, and he will ask you about it.
يعني في written questions؟
مفيش written questions. بس هو هيسأل أو يطلب منك إنك تختاري elementary operations. مش هتعرفي تختاريها أو تعمليها أو تدي الأوتكم إلا ما تحسبي. هتحسبي إزاي؟ عن طريق operations. She is asking me. Do you understand her? No. Okay. Very good. She is asking me about the final exam. All the exams. The exams of the previous years, most of them were MCQ exams. So we are talking about 16 questions, and each one of them contains 5 alternatives. The trick here is you have penalty in linear algebra. And also, each question out of these 16 questions, the alternatives may be all correct, some of them correct, or none of them correct. Okay? This is the tricky part. So actually, each statement within each question, you should be very capable of justifying or understanding or testing this statement. Okay? So they were asking, do I have to write the operations? Like this guy, do I have to write, I multiplied the first row by 2? In other universities, we don't have to write it, because we are not going to need it. We will focus with the final answer. But here, you will be asked about some of the steps that you did. In a way, you will see it down the road. For the time being, all I want you to know that I can replace rows. I can multiply a specific row by a certain number if I want to. Okay? Okay. The third operation is to multiply, to choose one of the rows, multiply it by a constant, then adding the result to another row. معايا؟ Let's see. I have row I and row J. Row I or the ith row and the jth row. معايا فيصل؟ بص كويس؟ I will get the sum of the ith row with the jth row multiplied by beta, which means I will multiply the jth row in beta in my mind. Then I will add each element from the jth row on the ith row. Look, it's A, I1, which is this element, plus that one times beta. Same way like, for each one of them. Let's do it. I want you to get the sum or to change the second row. In a way, it is gonna be the second row plus -3, the first row. Let's do it. So it's a 3, 2, 2, 2. I will multiply the first row by -3 and I will add it on the second row. جميل، ده لازم تشوفه. -3 plus بص -3 أنا بعمل multiplication for the first row -3, then I will add it on the second row. Let's do it. -3 times 1, it's gonna be plus 3, the result will be, I will do it once more. -3 times -1, it's gonna be 3, positive 3. Plus 2, so the result will be, I will do it once more. -3 times 2 is gonna come up to -6. Plus 2, so the result will be, once more, -3 times 0, say that, 0. Plus 2 is gonna be 2. So actually, all I did is multiplying the first row by -3 and adding it on the second row. But I'm doing this for each element. Instead of taking this rows, multiply it in -3, then take it and put it on this one. So that's the third operation. Can you memorize the 3 operations once more?
Yes.
Huh? Switching rows,
Switch rows.
multiplying one row by a number, multiplying one row by a number, then adding the result on another row. Okay? These are the 3 row operations. تمام؟
How do I know which row is the one that's supposed to have the results?
I will answer this question down the road. Okay? But for the time being, it's enough for me that we are capable of multiplying certain row by a number and adding it on another row.
مش L2 هو row 2؟
ايه؟
مش L2 هو row 2؟
مش فاهم.
L2 it means row 2.
L2 means line 2. For them, they write instead of row, line. Okay? But it is the same. Okay? Okay. He's insisting in this slide that you should write the process that you are doing. So mean the matrix M is obtained from A by elementary row operations. What I want to say is those elementary row operations, row operations, if you do them or you perform some of them on a matrix, you will get an equivalent matrix to the main one. So there is an equivalency here between the first matrix and the matrix that you make these changes, the row operations. Either multiplying a complete row by a number, or adding a row on a row, or multiplying a certain row by a number and adding it on the corresponding elements, you will get equivalent matrices. This will be written down in these matrices. Here we go. The matrix A, which is M by N, is row equivalent to B, equivalent to each other, if B is obtained from A by a sequence of elementary row operations. يعني أنا حبيت إن أنا أعمل more than, if I like, to do more than one row operation on a certain matrix for a specific purpose, the M, I will end up by having an equivalent matrix to the original one. Okay? Okay, some of these propositions or some of these, actually most of these row operations will be reversible. يعني If I change the rows 2 to 3, I can re-change it back from row 3 to 2. If I multiply the second row in 2, I can get it back to its original form if I multiply the new matrix by 1 over 2. Okay? If I added a multiple of certain row on another row, I can get it also or get its inverse also same way like. Just a second. أنا عايز أجيب لك الانفرس بس. أيوه هنا. بصوا if I doesn't equal to J, if I have IN and I'm going to E, Li into Lj, I can replace it by moving vice versa, moving Li into Lj. يعني أبدلهم تاني. يبقى switching row number 2 into row number 3. If I switch back row number 3 into row number 2, I can reverse this process. If I'm multiplying by alpha, it can be reversed by multiplying this row by 1 over alpha. Yani if the second row I want to multiply by 3, I can reverse the process by multiplying the same row or the final result by 1 over 3. Also, if I have Li plus beta Lj, I can inverse it or replace it once more by doing the same, but with Li minus beta Lj. And this is the elementary operations that we talk about. Before we go further, I want to show you something really very interesting. Regarding these row operations, I skipped this part for the time being just to give you these examples and these remarks. So I've skipped the 2 or 3 slides that I went quickly on them because I want you to see these relations. Let me go through this matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, and 1. This is what's called a unit matrix. Let's say I will make the examples on a 3 by 3. This is a unit matrix which is 3 by 3. The advantage of the unit matrix is if you multiply by any matrix, it will remain the same. We already know that. Okay, if I have another matrix, which is matrix A, that's 3, 2, 1, 4, 5, and 6, 7, 8, and 9. Those are the elements of this matrix. Okay, remark. If I want to replace the second row by the third row, I can do it by multiplying the matrix I, but I will change its rows. So it's gonna come up to 0, 0, and 1, then 0, 1, and 0. Then I will leave the first row as it is. اللي أنا عملته ده دي elementary E1 elementary matrix, which is gonna replace L2 in the position of L3. Okay, ده اللي أنا عملته. I've changed the second row instead of the third row. If I multiply this matrix by 3, 2, 1, 4, 5, 6, 7, 8, and 9, what's gonna happen? تعال نبص كده لو انا عملت مالتيبليكيشن الماتريسيز دي ببعضها. اعمل معايا كده، هضرب الفيرست رو في الفيرست كولم يقوم يديني 3، بعدين اضرب الفيرست رو في السكند كولم هيدي لك 2، الفيرست رو في السكند كولم هيديني 1. So the first row after multiplication stayed the same. Let's remark the second row here. Multiply the second row by the first column. 0 times 3 is going to be 0. 0 times 4 is going to be 0. 1 times 7, so this value is going to be 7. Multiply once more the second row in the second column. What's going to be? It's going to be 0 times 2 plus 0 times 5 plus 1 times 8, which is going to be 8. Multiplying this second row by the last column, it will remain 9. Then once more multiply the third row by the first column. So it's gonna be 0 times 3, 1 times 4, and 0 times 7, which is gonna come up to 4. Multiply the third row by the second column. It's gonna be 5. the third row by the third column. So it's gonna come up to 6. Please look at these two matrices. What happened in them? What's the difference between them? We already switched the rows, if you remark. So the idea of considering the elementary matrix or the unit matrix, doing whatever you want to do, but replacing the rows or multiplying the rows, whatever you do here, it will make an image in this matrix to perform the same procedures. So here I switched the second row instead of the third row. Okay? So this is called E1, which is responsible about replacing rows in the place of each other. طيب بص كده، لو أنا حبيت multiply the first row by 5, how to do it using the unit matrix? This is gonna be E2, or the process number 2, which is multiplying certain row by a constant. All I have to do simply is to consider the unit matrix. Here I need to multiply 5 in L1 or 5 in the first row. So all I have to do is to get the unit matrix, multiplying 5 by the first row. Then that's the new matrix, which is 3, 2, 1, 4, 5 and 6, 7, 8 and 9. And in a similar manner, you will find that the first row is multiplied by 5. Let's do the multiplication. So I'm going to multiply the first row by the first column. So 5 times 3 is going to be, multiply the first row by the second column. So it's going to be, multiply the first row by the third column. So it's going to come up to, once you try to multiply the second row by the first column, it will remain the same. So it's going to be 4, 5, and 6. Once you try to multiply the third row by the first column, it will remain the same also. 7, 8, and 9. This is how we perform the second row operation, but with using the elementary matrix. This is called the elementary matrices by the idea. So I have row operations, which are switching, multiplying certain row by a number, multiplying certain row by a number, and adding it on another row. What's the elementary matrices? They are unit matrices. I will perform in them the same steps that I want to have. And once you multiply it in any matrix, what you aim is going to happen. So let's try it finally. If I want to, multiply the first row, I will write it above, I write it in the top of this board. Okay, that's the main matrix. If I want, this is E number 3, the third step. If I want to multiply the second row by negative and adding it on the first row, how to do it? Very, very simple. So here I will multiply second row by -1. Then I will add it on the first row. تعال نبص كده ايه يبقى شكله عامل ازاي. اولا دي اليونت ماتريكس. اعملي في اليونت ماتريكس كده. يبقى السكند row I will multiply it in negative. So it's going to be 0, -1 and 0. Then add it on the first row. That's the first row. 1, -1 and 0. The second 0, 1, 0. 0, 0, 1. شباب انتوا عارفين دي انا جبتها ازاي؟ I've multiplied the second row by negative and then added it on the first row. مش unit matrix 1 0 0 0 1 0 0 0 1. انا عايز اعمل negative L2 plus L1. So I've considered the second row, multiplied the negative, then added on the first row. تعال بص كده لو انا حبيت اضربها اعمل لها multiplication في الماتريكس. معلش هكتبها هنا علشان اعرف ادي الريزلتس جنبها. 3 4 and 7. 2 5 and 8. 1 6 and 9. ادي الماتريكس بتاعتي. بص كده زياده. اعملي multiplication من first row في first column. يلا 1 times 3,
3
negative 1 times 4
negative 4
مجموعهم
negative 1
0 times 7 خلاص. Multiply the first row by the second column. 1 times 2 بعدين negative 5 which is gonna come up to negative 3 بعدين 0 times 8 خلاص مشي. اضرب the first row by the third column. So it's gonna be 1 minus 6. The sum of them will be negative 5. Multiply the second row by the first column. It will remain the second row, as you can see. Multiply the last row by, the last row by each column of these columns. It's gonna be 7, 8, and 9. If you remark, whatever you do in the elementary matrix, it will happen, it will be reflected on the main matrix once you multiply. بص كده يا ندى. Multiply the second row negative and add on the first row. Negative 4 plus 3, negative 1. Negative 5 plus 2, negative 3. Negative 6 plus 1, negative 5. Okay? These are called the elementary matrices. It is written in here. I skipped this one while we are scrolling just in seconds. This is E1, just replacing the second row instead of the third row. Okay, this is the E1. E2, multiplying a certain row by a number. So here, for example, I've multiplied the third row by a 7. This is E3, which contains a multiplication of a row and then addition. So here I've multiplied L2 by, then added it on L3. يعني ضربت the second row in by وadded the result on the third row. Those are really very important part. I will continue next time inshallah. طبعا same can be done with columns as I told you, but we will be focusing more with the row operations. So before you go, how many row operations that we have? 3 of them. Replacing rows, multiplying a row by a number, multiplying a row by a number, then adding it on another row. Those are the elementary matrices. What are the elementary matrices? They are unit matrix from a certain size. And you perform on them the process that you will do. Once you multiply it by a matrix, it will perform the process. If I into E, where T is an elementary row operation, then A is equal to E times A. E stands for the I matrix after you do your interchanging rows or whatever. This is really a very important slide. And a whole question usually hunt this part in midterms and final exams. I've already mentioned that to you. It's really very important. Because, I'll tell you just in seconds, those are the switching rows, row multiplication, row addition. ده السمري بتاع اللي احنا عملناه من شوية, row operations. Next time, inshallah, okay, we will focus more on the pivots, how to get a pivot. We will start to see how to use these row operations in order to get the row echelon form or the reduced echelon form, which is really very important. We will see it down the road. I will stop here. And before you go, do you have? I'm sorry, Ziad. We are done from today's lecture, so please stop recording.